Alright, Task 2. Describe theory, principles, procedure for the welding armor plate, methods, destructive, non-destructive test welding, and troubleshooting. Introduction. The previous task described the methods, classifying electrodes, type of the intended for the use of the automotive welding materials, identifying the process, the type of the techniques of the joint design. Previous information provided for the basis of the task, which described the theory, principles, procedure for the welding armor plate with the method of the destructive, non-destructive testing and troubleshooting of the welds. 2. Armor plate uses. Armor plate used on tanks and self-propelled guns, other combat vehicles, protection, personnel, equipment, the destructive force for the enemy projectile of the fabric, both in the form of the casting and rolled plates, whichever the heat treated developed and desired structural and protected property for the manufacture of the gun turns the current combat tank hulls, including one piece of casting, welded assemblies, rolled plates in the section that have been casted. Repair of armor plate welding or replace the riveting and repairing with the armor plate, although in some cases the riveting is still on some of the vehicles protected with a face hardened armor. Developing on suitable techniques the welding armor plate depends on consideration following factors affecting weldability of the armor plate. 1. Knowledge of the exact type of the armor being welded. Knowledge of the proper repair method. 3. The function of the damaged structure. Proper section of the selection of welding materials to prepare. The procedure. The urgency of the repair required to accomplish the combat mission. Carefully analyze the defective terms and properly joint electrode, current, voltage, polarity, minimum welding stress, and warpage during the repair. 7. Knowledge of the hazard, safety, hazard procedure, the theory of principle, procedure of welding armor plate are basically the same as those in industrial fabrication, but must be modified at times because of the very type of the damage can be occurred in battlefield. Welding armor plate. Property of the armor plate. A property of the armor plate hardened with normalized heating with the upper critical point, letting into cool still are the base metal quenching of the effect of the produced next to a welded heavy armor plate under the normal condition of is about halfway between the effect of the air cooling and oil quenching it. During the welding armor plate, the temperature of the welding metal ranges up to 3,000 degrees Fahrenheit from original temperature of the base metal. Therefore, a narrow zone on each of the deposited welded metal is heated above the critical temperature. The narrow zone is quenched by the relatively cold base metal because of the hard or brittle zone known as the martensite. In zones of the cracks are more likely to occur with the application of the load. For the reason, special precautions must be taken with the welding operation, minimizing the formation of the hard zone. In addition, with the care must be taken to prevent rapid cooling of the armor plate after the welding in order to avoid formation of the cracks in the hard zone. Type of the armor plate. The general two types of armor plate used in the combat vehicles: homogeneous, which can be casted or rolled or face part, and with the roll, which is rolled essentially with the armor plate, with it specifically identified because of the welding and the cutting operation performed. This is important because the welding procedure for each type of the armor is distinctly different from the not interchangeable homogeneous armor plate. Homogeneous armor plate is heated and treated through its entire thickness for the developing good shock for the impact. The resting of the property of the type of the armor is uniformly in hardness, composition, structural throughout that can be welded on either side. Aluminum armor plate with the homogeneous class of the welding procedure for the armor plate of the same as for gas metal arc welding, which discussed an aeric gas of the welding operation subcourse. 3. Face hardened armor plate. Face hardened armor plate has extremely hard surface for layer that is obtained with the carbonizing. Carbonizing is the process of combining carbon with another alloy. Of impregnating metal with carbon strength is the surface extent with the depth of 1 1/5 or to 1/4 of the outward face thickness of the armor of the tank armored vehicle. The primary purpose of the face hardened armor is to provide with a good resistance against the penetration of the enemy projectile of the inner side with the comparative soft and the house properties similar to those of homogeneous armor. As a matter of fact, the inside and outside of face hardened armor's plates have different kinds of steels. Face hardened steel with up to 1/2 inch of thickness should be welded from the soft side only. Identification of armor plate. A very important part of the welding lies with the welder having the ability to identify the part of the metal to be welded. The following paragraphs describe the two samples of accurate tests that may be made in the field shop of identifying armor plate. 1. The file test. The type of the test performed with the use of the ordinary file found in the mechanic's welder tool set. 2. Homogeneous armor. File with a weld bite into the homogeneous armor on the both outside and inside of the plate as the file down across the either surface of the armor plate with the teeth of the file and with the bite of the end of the metal, making it necessary to apply with the force of the draw and the file across the metal. The type of the test is applied by applying the file only once or twice across the surface of the armor. Protection quality of the armor plate can be impaired with the repeated application of the file. Therefore, the number of applications should be limited. B. Face hardened armor. In the type of the armored the file will bite only with the soft side of the hardened armor plate, while the armor across the face side of the outside of the armor plate file will slip instead of the biting on the metal. When file is applied, the reverse side inside of the file will bite homogeneous metal. 2. The fracture test. Some metal can be quickly identified looking at the surface of the broken part with the chips produced with a hammer or chisel. Homogeneous armor. The metal at the edge of the hole of the crack is made with the anti-tank projectile homogeneous armor plate with ragged bent and with the metal drifted in the direction of the penetration. Cracks on homogeneous armor are usually caused by the stress or metal, but these cracks are present with the severe bulges or bends in the damaged armor plate. B. Face end armor. The metal edges, the holes and cracks in the face end armor are relatively clean and cut and sharp. The plates do not bulge and get any extent with the cracking. By examining the edge of the fresh broken face hardened armor, it can be noted that the metal of the face side is brighter than the finer structure of the metal on the soft side. The brighter the metal extends to the depth approximately 1/5 to 1/4 inch in thickness to the outside of the surface. 4. Cutting armor plates. Homogeneous armor plate. Either the oxygen cutting of the electrical arc can be used to cut the homogeneous armor plate. Oxygen cut torch. However, preferably the carbon can be used to cut off the welds to cut casting plates, but the shield metal arc is preferably oxygen and acetylene are not available. Face hardened armor plate. Generally, the procedure for the cutting type of the armor is essentially the same as described for the homogeneous armor. However, every precaution should be taken to keep as much of the heat as possible away from the hard surface side of the plate. This is by cutting on the soft side of the armor plate. Cutting from the soft side limits the extent of the heating of the consequently softening side of the harder face side. Cutting with an oxygen torch. The general practice for the oxygen torch can be applied with the cutting of the armor plate, but the tip size and cutting oxygen preheating gas temperature should be kept at the minimum, consisting of the good quality of the cuts and to prevent the overheating stainless steel with the non-oxidizing metal. Therefore, when the cutting of the steel type welds with the oxygen cutting torch, it is necessary to use the oxidizing steel rod. The oxygen combines with the metal of the steel rod, creating the high temperature drops of the molten steel. With the drop of the molten steel washing out onto the weld to help the metal stainless steel weld. The washing action with accomplishing a facilitating motion with the torch tip, causing the molten metal to wash away with the liners, while the thickness for the steel welders are cut in a steel rod should be against the side of the weld, divided downward slowly to generate the high temperature required created with the molten steel. The drop and cutting process using the steel rod is illustrated in Figure 25. Alright, Figure 24 shows the overhead fillet welding position. The Figure 25 shows the cutting stainless steel weld. Cutting tip steel rod, depth of the cutting tip, then steel welding weld. Alright, crack the defect face of the stainless steel weld to remove the holding the cutting of the type at the slight angle away from the face of the weld, shown in Figure 26. The reaction between the cutting and oxygen steel rod develops sufficient heat to melt the welded metal and then wash away after the joint surface can be re-welded. Figure 26 shows the removal of surface defects of the stainless steel welds, steel rod penetration, flames, motion of the cutting tip, cutting the oxygen, molten steel particles, molten slag, and section of the weld. Arc cutting with electrical arc. Electric arc cutting with the procedure whereby cutting is using the heat of the arc maintained between the electrode and the base metal of the procedure described in the following subparagraph. Are used for the cutting of electric arc. Carbon arc cutting is a process whereby cutting of the metal is accomplished by the aggressive metal with the heating of the electric made between the metal electrode base metal with direct current, straight polarity electrode negative performed. The carbon arc is used in some conditions in conjunction with the jet compressed air with the removal of the defective austenitic corrosion resistant welded metal. Cutting with the carbon arc with the cutting of both ferrous and non-ferrous metals, but does not produce a cut with a particular good appearance. The electrode are either carbon or graphite, preferably pointed end of the red reduce the air arc wandering of this, producing less erratic cuts. Through metal arc cutting is the process where the cut is produced with the progressive metal melting the metal. The direct current straight polarity performed for the process of the coating of electrode range from the diameter of 1/8 to 1/4 inch for the use of the larger diameter. If non-satisfactory prescribed excessive splatter thickness for the metal can be then cut with the metal arc process limited only by the length of the electrode. The coating on the electrode serves as an insulator between the core of the electrode and the side of the wall of the cut, resulting in less short circuit against the curve. Cut made by the metal arc process are less ragged than produced with the carbon arc, but they must be still prepared with the grinding and chiseling before re-welding is accomplished. Alright, oxygen cutting is accomplished by directing the steam of the oxygen into molten pool of the metal. The pool is kept molten by the arc struck between the base of the metal with the coated tubular cutting of the rod. The rod is consumed during the cutting operation. The tubular rod is provided with the oxidizing flux, means of converging oxygen onto the surface of being the cut. The tubular cutting of the electrode is made with the mild steel contamination with the metal, eliminated with extremely high heat oxygen emitted process. The high heat of the oxygen also oxidizes the rod, thereby preventing the rod from fusing with the base metal. After completing the cutting with the cutting and the process of the rough edge and slag should be removed with the hammering and chipping the grinding with the wire of the welding. Welding homogeneous armor plate. The general before welding damage to the armor plate, the type of the armor must be first identified. The identification can be accomplished by in the field with one of the methods described in paragraph 2C of the page 63. Homogeneous armor plate can be satisfactorily welded with electric welding arc process. And 18.8, the stainless steel with the heavy coated electrodes, reverse polarity armed vehicles have them being exposed to conditions with extreme cold should not be welded until the base metal has been preheated sufficiently to bring the temperature to the base metal zone of the welding are not less than 100 degrees Fahrenheit. The temperature of the metal is not noticeably allowed to warm to the touch. If the preheat is not applied, the cracking will occur with the deposit welded metal. Procedure 1. The simple cracks are shown in figure 27 of the view A with the following page showed to be in the flame cup, the bevel V joint as shown in figure 27 of the view B with the welding care should be taken to round off the corners of the toe of the root of the joint with the necessary in order to eliminate excessive welded metal dilution, including the angle of the bevel shown in figure 27 of the view C with the should approximately 45 degrees between provided electrode making the root weld beads. The rooting opening should be in figure 27 of the view should be 3/16 to 5/16 of an inch depth on the plate thickness. The welded beads deposited with the root of the weld must be good quality. Essential care must be taken to prevent cracks, oxide, slag, inclusion, incomplete penetration, excessive weld dilution in this area. Some of the methods recommended the preparatory steps of the root for root. Figure 27 shows welding crack homogeneous armor. Beading welding shown in figure 28 for the narrow opening 3/16 within stainless steel electrode without the coating of the B tack with the place and shown in figure 28. Welding B numbers 1 through 4 are the deposits equally ensuring the sound weld remove all the slag oxides from the joint before the depositing blades 3 and 4. Mild sealed the rod strips and shown in figure 28. View B, the backside of the backing routing. The stripping should be chipped off out after the beads 1 and 2 are deposited, minimizing dilution on beads 3 and 4. Using stainless steel strip at the backing of the root beads as wide root opening is shown in figure view C of figure 28. An alternate figure 28 shows the root bead welds. Alternate method shown in figure 28, the UD of the previous page, mild steel strip. The wind method is chip the backing of the rod strip, chipped out with the 4 to deposit 3 and B. Beads 3 and 4. Another procedure shown in figure 28 view and E. Usually the copper backing bar of the copper back of the removed with the beads 1 and 2 with the deposit of the beads will not be welded. The copper bar beads in 3 and 4 deposit after the removal of the copper bar in certain locations of the where plates are homogeneous armor cracked along with their entire cross with the section plate with another method of joint preparation shown in figure 28 view F. Also use them other methods roots base A and B deposit opposite form at each of the other and base level of the roots. Beads acts as backing and backing for the beads 1 through 6, which are deposited afterwards. Welded crater fusion cracking, fusion zone cracking, especially with the root beads manufacturing involved with the welding cracks armor with the terminite with the plates, prevent cracking the intermediate backstep overlapping position shown in figure 29 view A with the following page recommended. Should be noted that all the welding steps necessary for the bead number 1 must be completed after depositing bead number 2 by the backing of the stepping craters that end of the previous path are located and filled. All craters subsequent path for the do not terminate the previous deposited metal should be filled with a hesitation drawback technique. The filling up the metal welded crater avoids the formation of the star cracks, which are caused by solidification of shallow, deposits of molten welded metal. Each pass with the bad beads 1 through 4 shown in figure 29, views B and C limited to 1 and 2 inch of the length, which should be painted with the welded metal with help over the cooling of the stress. No electric weave of the motion should be used when the root beads are deposited. The welding should be performed preferably with 5/32 inch electrode. Painting also tends to eliminate minimizing warp. The section being welded, the arc blowing should be controlled by the project per adjusting method of the welding of the some or more common defects encountered with welding roots and beads with the homogeneous armor and proper remedial procedure shown in figure 30, page on 74. Alright, page 29 shows the welding bead homogeneous armor plate. Page 30 shows the homogeneous armor common defects remedial procedure. The sequence of the welding beads procedure recommended to commonly weld the single joint V joint with the shown figure 31 with the following page. The welding should be performed with 5/32 and 3/16 inch electrode. The electrode is directly under against the side of the wall of the joint with the show of the form that approximately 20 to 30 degrees of the vertical. The electrode should also be within inclined 5 to 15 degrees the direction of the weld by the producer of the sidewall penetration. Effectively controlled electrode weaving motion should not be exceed 2.5 electrode core wire diameter. The important process to be this is important because the stainless steel has a coefficient of expansion approximately 1 and 1/2 times the mild steel, and if in weaving motion. Figure 31 shows the welding single V joints homogeneous armor plate. Greater than the recommended use longitudinal shrink of the crack of the weld fusion zone developed the sequence pass with the use of the complete filling the double joint shown in figure 32 of the view A and through C of the following page. The depth of the penetration welded with the metal with the basin should be controlled in order to obtain the good fusion and excessive dilution of the weld. Figure 32 shows the welding of double V joints on the homogeneous armor plates. Excessive dilution will cause the weld to be non-stainless steel brittle with the subject of the cracking. The poor proper penetration will give the long scallop the heat effect of the zone on each side of the weld shown in figure 32 of the UD on the previous base. Insufficient pressure penetration surface fusion will provide with a fairly straight edge for the heat effective zone on each side of the weld. The condition undesirable to standpoint with a good ballistic property. The better control can be maintained in the heat input of the joint with the shape of the joint and alternately depositing the welded metal on one side of the joint and then the other. Each of the layer of the metal deposit with the severe stress to relieve the welded metal immediately beneath it. The material partially tempered by the heat effect of the zone produced by the base metal previous to welding made. The passage of the toe welded joint shown in figure 32 view C will also serve the anneal of the base joint. Base metal deposits before intermediate passive that are added to the fill weld joint anneals the passage of the toe of the weld. Well, the joint are an important factor for eliminating fusion zone with cracks and might start the surface of the weld through careful control of the depth of the preparation and penetration heat affected zone with the scallops effects of bruise. Emergency repairs. Two methods of emergency repairs are repairs on cracked armor plate that can be made using a butt strap as shown in figure 33 of the EN5 with the following page. The straps are welded to the back of the cracked armor plate with the primary purpose of the back strap, butt strap to strengthen the section weakened by the crack. The repairing the penetration complete penetration homogeneous armor plate repaired with the procedure shown in figure 34 through 36 on page 79 through 81, figure 35A on page 80. Then show that the considerable structural damage has been done to the metal indication adjacent with the shell penetration. Shell penetration has smaller than thickness for the armor of the plate can be repaired. Butt strap method to effect the repairs. The all torn irregular edge of the damaged metal should be removed. Then permit good contact between the butt straps and the base metal armor. Figure 33 shows the butt strap of the weld with the cracked armor plate. The plates are shown in figure 34 for the following page for the holes or larger than thickness of an armor plug with a plug patch for the homogeneous small thickness for the base metal should be used within shown figure 35 for the view B page 80 with the correct and incorrect method of preparing welding plug patch shown in figure 36 for the view A and B with the page 81 small diameter penetration can be repaired by plug welding without using the patch. Repairing bulges in armor that is also cracked that do not interfere with the operation internal mechanism in vehicle can be repaired. Welding the cracks in section U of the procedure described in paragraph C above. The results of the bulge should be cut out with the patch inserted with the bulge's armor interfere with the operation. Internal mechanism may be removed by grinding or chipping them away. In all cases, the weld should be made with the full thickness of the plate with the cracks over a quarter inch width. This should be chipped out with the 4 welding repairs made with the one side where there is not feasible the weld repair on both sides of the armor. The joint must be then made from one side of the shown figure 31 on page 75. Note that either the butt strap or the stainless steel can be used to back up the root beads of the weld. Figure 34 shows the emergency repairs. 35 shows the double V plug welding, double build-up sequence welds. 36 shows the correct and incorrect plugging weld penetration. Or repairs with non-welded butt strap. The techniques permitted for the removal of the butt strap after the welding is shown in figure 37 of the view A. The technique for the application where the butt strap would interfere with the operation of the internal mechanism that permits the welding single V joint of the homogeneous armor plate without welding the butt strap with the welded metal. This technique, 37 with welding without a butt strap. It requires the increase of the angle of the electrode 60 degrees, shown in figure 37 of the VUB with the previous page for the metal of the weave to simultaneously increase of the weaving speed as a result of the welded metal deposit for the base metal. Previously deposited metal instead of the adhering with the butt strap at each end of the weave with the angle of the electrode decreased with the 15 degrees, shown in figure 37 of the VUC. Simultaneously waving the speed of the electrode is helped with the monetarily adjacent to the side wall and ensure the good side wall penetration. After depositing the root with the spade patch for the butt strap can be removed with the backing of the tack welds, but which secure for the armor plate with the final patch can be applied with the root weld after removal of the butt strap. Repairing gouges. Occasionally a projectile for the impact of the armor plate at an angle only a gouge without a penetration effect of the repair. The gouge should be prepared with a double V joint with shown figure 38 view A with the following page with allowing the weld to be both sides, merely filling with the gouge with the welded middle is shown in figure 38 view B with a satisfactory sense it holds and removes any subsurface cracks that may have been caused with the shell impact. Also having their own produced the base of filled in gouge has poor ballistic strength. Welding face hardened armor plate. A. General. The face side of the hardened armor is extremely hard and brittle with the cracks. The type of the armor can be welded to satisfactory. The soft side of the cracks can be repaired using an 8 by 18 by 8 Stainless steel reverse polarity, heavy coated electrode, special precautions, however, that must be taken to avoid distortion successfully. Heating of the armor plate. Distortion successfully. Heated plate must be stressed with the base metal, causing the plate to face with the correct satisfactory method of welding. The type of the armored plate makes the butt strap of the welding technique shown in figure 3940 with the H for 85, 89, 86 for the dimension of the butt and strap, depending on the thickness of the armored butt strap. The dimensions are armored pub, the 1 inch thick are. Our figure 38 shows the penetration gouge of the homogeneous armor plate. Provided with a technical manual 9237 and the desired butt strap as well with the soft side of the armor through the elongated slots cut in the strap of the slots, then completely filled with the plug welding. Do not use excessive weld reinforcement undercutting it in the surface of the plug. 39 shows the butt strap weld to the face hardened armor plate. The 2-seal crack of the face hardened armor plate shown in figure 40 view of the following page again for the splatter. Make it watertight with the seal bead for the soft side. Grind it flush before applying with the butt strap. All welding should be performed on a clean scale surface. Previously deposited welded metal should be thoroughly cleaned by chipping the wire, brushing, and the removal of slag oxide to ensure the sound welds. Alright, figure 40 shows the sealing crack in the face of the hardened armor. Crater cracks eliminated by the backstep overlap procedure by using the electrode hesitating drawback technique. Crater cracks in the form of the initial weld bash they should be chipped out, but an additional weld of metal applied. They can be welded out successfully by subsequential passes. The precaution string beads should be used for the initial pass. The subsequent passes do not weave the electrode more than 2.5 times the electrode core of the wire diameter. The efficiency of the joint but welded by the method depends upon the good fusion to the base metal on the side walls of the slot and the butt strap. If the straightening is necessary, use the hammer only on the soft side of the face and the harder arm of the butt strap on the plug weld. Do not hammer on the face side as the rule forces should not be applied with the straight force on the hard armor that applies the force, producing tension on the face hardened side. When 2 or more butt straps are used to prepare the irregular cracks to make patch weld the butt straps and weld together additional strength as shown in figure 41. Figure 41 shows as different butt straps welded together. Armor plate repair methods. Corner joints can be repaired by using the angle iron, but the straps are shown in figure 42 with the procedures. In fact, the type of the repair was the same as those used in making the plug wire welds of repairing cracks in the face armored armor, described in paragraph 682 at the beginning on page 83. Figure 42 shows the corner joint and an armor plate. Generally, the butt strap method is satisfactory repairing with 1 inch of the thickness of the face for the hardened armor. However, they usually only use the thickness up to including 1/2 inch of another as tip the procedure. Welding face armor above 1/2 inch of thickness of the double V joint method is shown in figure 43. The WAP method requires the soft edge of the plate to be V joint welding with a hardened armored plate. To be completely welded before welding on the face side, using the string bead weld to backstep overlap of the procedure with the root pass to reduce the danger crack, developing the weld, keeping the structure free of the warpage, nor weaving motion or welding rod should be used in the type of the joint. The modified procedure known as the depressed joint method, shown in figure 44, view A, is used with welding up to including 1/2 inch thickness, thick face hardened armor plate. This method is used in 1/8 of an inch. Figure 44, depressed joint with the face hardened armor plate and the seal beaded welds of 1/4 inch stainless steel by which the blazed and damaged portion of the armor plate in this bead weld in place. The principal advantage of the joint and its simplicity, good structural ballistic properties. Care should be taken that no welding is done with the hard face side of the armor. The armor plate welding electrode is the most satisfactory method for repairing a homogeneous face hardened armor and plate arc welding process and stainless steel electrodes. 2. In the oxyacetylene welding process, a large section of the base metal must be heated to maintain the welding pool weld satisfactory. The heating will destroy with the heating and the treatment. The base metal covers the large area structurally ballistically weak. In addition, with the process flow produces considerably warp at the base metal. Initial development of the armor plate for welding repairing required the use of stainless steel electrodes containing 25% chromium and 20% nickel. For the development to produce electrode of the core, 18% chromium, 8% nickel. The coating magnesium molybdenum both produce excellent results. The electrode known as the magnesium modified 18-8, the molybdenum modified 18-8 stainless steel electrodes. They can be used for the welding all types of armor plate by electric arc processing without heating of the post heating of the base metal structure. R4. Current and polarity. The extent required for the arc with the welding electrode previously discussed depending on some extent with the joint type, electrode design, and position of the weld limited to be below the recommended welding current settings listed. The direct current, reverse polarity, or position heavy coated modified 18-8 steel electrode, stainless steel electrodes. Electrode diameter 1/8, current range of amperes 90 to 100, 5/32 inch, 110 to 130 amperes current range. Strength riveted joints in the armor plate. The button head riveted joint. Strength the button head rivet the joints in the armor plate. Seal bead weld. Recommended show figure 44 view B on the page 90. To apply the bead of the arc is struck with the top of the rivet using the stainless steel electrode. The electrode is held above the top of the rivet long enough to meet the approximately 1.5 inch of the electrode. The electrode is then moved with the curved surface of the rivet down to the armor plate with around the edge of the rivet until the rivet is completely welded around the plate. Rivet and then homogeneous armor plate with it can be sealed welded on both sides of the rivet joint is faced with the hardened armor. However, this should be sealed with only with the soft side of the plate. B countersunk rivet. The countersunk rivets are sealed with the same manner as the button head rivet joints. Advantage of the welding rivet joint sealed bead welded rivet joints prevent the riveted having the shearing off the rivet, shanking the punching them through the plate until the projectile impacting on the armor plate. Testing of the welds. G. To ensure the satisfactory performance of the weld, the structure quality of welds must determine the adequate testing procedure of the welding structure. Therefore, must be approved to test under conditions but the same with more of the serve than those of the found in the field. To test of all the serve to determine the proper welding design, forestall the injury, inconvenience, the ultimately failure of the material. Generally, there are two types of tests that can be performed to ensure the satisfactory performance of the welding structure. They are the performance and physical types of tests. Performance test. Material prepared by the standard welding procedure may be tested operating with the maker performing the function with which the design. For example, the weapon can be tested with the firing and an extra charge determining the safety of the weld. A wheel vehicle can be tested with a high speed over the rough terrain. Welded armor plate. Other heavy structural members to be tested with the gunfire. The testing of the weapons. The testing of the armor plate by the gunfire is not feasible. The maintenance units of the field. The succeeding paragraph therefore describes only the physical type of the test can be conducted in intermediate direction, general support maintenance and units of the field, depot maintenance operation in continental United States depot maintenance operations. 1. Physical test. Generally, the type of the test is designed to check the skill of the welder, quality of the welded metal, with the strength of the welded joint. Some of the tests, such as the free bend, the nickel break test, the deductive test, the specimen test with until the fair oils in order to desired information can be gained. Other physical tests, such as the hydrostatic magnetic particle test, and non-destructive. Then they are simple physical tests, such as the appearance and fracture grinding test that can be performed with the found with the field maintenance company shop. The simple physical tests are described in the following subparagraph. The destructive, non-destructive type tests is described in the succeeding subparagraphs. Simple physical test, appearance test, the non-destructive test, the type of the test, the visual examination made of the weld to check such defects, such as brittleness, cracks, craters, undercut, overlap, slapping, inclusion of the defects unacceptable. The joint must be reconstructed. Fracture test, the destructive test to perform the test of the cross-section specimen must be cut off from the welded metal with the specimen is fractured to expose the weld. The weld is done visually examined to check the unevenness for unevenness. The weld metal, the grain of the craters and the cracks and craters inadequate penetration of the weld into the base metal. See grinding test, the non-destructive test, in particular applicable seal bead made for the waterproofing and sealing cracks in the face hardened metal. With this strap must be ground flush, down flush with the base metal before the welding of the strap, and then reinforced with the damaged area. After the grinding of the weld is visually examined, the product check for the proper penetration, craters, cracks. Even if the welded metal game, the destructive, non-destructive test in the following subparagraphs will describe the total of the 6 tests. The destructive 3, non-destructive 6 tests are one of the most likely to perform in the maintenance unit of the field depot maintenance operation. More information other than tests is desired is provided in the technical manual 9237C. 9237 destructive test 1 guided bend test. This test serves to determine the quality of the welded metal with the phase of the root of the weld, the groove of the penetration fusion to the base metal. These tests are made with the jig on a jig as shown in figure 45 of the view A with the following page. The jig can be fabricated to any size of the desired of the field maintenance of the company machine. To perform the test specimen must be machined from welded plates to the thickness of the capacity of the bending jig. The specimen then placed across the die supports the weld on the specimen must be centered on the U and the portion of the die. The plunger is then lowered onto the specimen above the hydraulic other than device the specimen into the U portion of the die. To fill the requirement of the test specimen must be 180 degrees and have no cracks greater than 1/8 of an inch on the surface. See both bases of the bend of the root bend test was welded shown in figure 45 of UB with the can be formed on the jig. To perform the face bend test, place the face on the welding face on the jig, and the root bend test is performed placing the specimen on the die with the face of the welding face up. Alright, figure 45 shows the guided bending tested jig. Face up and root bend. Alright, your free bend test. The free bend test has been divided for the measure of ductility, welded metal deposit, welded joint, and the test specimen machine with the welded plate with the weld located in the center of the shown figure 46 of the UA with the following page, each length with the edge of the specimen shown with the round of the tailor radius not exceeding 1/10 of the thickness of the specimen. The tool marks should be made lengthwise of the specimen, 2 lines for the opposite each of other described on the face of the weld where as described in the distance 1/16 of an inch toward the edge of the weld shown in figure 46 of the UB with the distance between the 2 lines measured with inches. Recorded initial distance of X, then end of the specimen that are then bent to form the 230-degree angles, approximately 1/3 of the length from the end of the weld is centrally located to ensure that all bends occur in the weld. B. Then the bent specimen is placed in the hydraulic mechanical machine shown in the figure 46 of the VUC with the bent all crack greater than 1/16 of an inch appear from the face with no cracks appear with the armor plate continuing bending until the specimen can be bent into a vise. Heavier plant specimens are usually tested at hydraulic press and bending jig to prevent slipping of the specimen groove. This should be machined with the upper and lower contact plates. Bending equipment shown in figure 46 view E. C. After bending bent to the specification prescribed and proceeding to subparagraph, the distance between the scribed line of the game with the bench recorded with the distance y within the percentage elongation used in the formula shown in figure 46. The test specimen must have the minimum elongation 15%, no cracks greater than 1/16 of an inch of the weld to pass the test. 3. Nickel break test. The nickel break test has been devised to determine the welded metal with the welded by joint with any internal defects like inclusion, gas pockets, pore fusion, oxidized metal, burnt metal. The specimen obtained with the welded butt joint, either machining or by cutting with an 46 shows the free bend test. Oxytilitane quartz. Each of the end of the weld, the joint is slotted with a hacksaw band with the shown figure 47 of the specimen with the ridge across the tool steel block stock. Struck with a heavy hammer until the section of the weld become between the slot fractures. The metal should be exposed with a complete fuse and the free slide conclusion. The side of the end of the gas packets must be greater than 1/16 of an inch widest point. Number of the gas packets pores should not exceed 6 per square inch. Another break test method is used to determine the soundness of the field weld is known as the field welded break test. The test should be performed applying the force of the apex of the V-shaped specimen, hydraulic press striking the hammer until the fillet weld ruptures and the surface of the fracture are examined in the same defects mentioned in the preceding paragraph. 47 shows the nickel break test. Non-destructive test. Hydrostatic testing test. The non-destructive test used to check the quality of the weld closed with the containers such as the rest of the vessel on the liquid tank. One method of performing the test in the field with the vessel with the water applied the pressure greater than the working pressure of the vessel. The outside surface of the vessel is observed leaks with the weld through the weld. Check the welds of the non-pressurized tank. They may be filled with water. Observe the seepage leakage through the weld. Magnetic particle test. The method of testing the welds partially made with the magnetic alloy is applicable to ferromagnetic materials in which the deposit metal with also ferromagnetic. A strong magnet field is set up with the ferromagnetic specimen electrical current to discontinue the metal with the seep of the leakage field with the local magnetic poles of its own. These poles track the magnetic particles sprinkled with the surface of the specimen indicate with the discontinuity overall pattern of the magnetized specimen. Discontinuities indicate the defects such as the cracks existing closure of the surface of the specimen. Fluorescent penetration test. The fluorescent penetration test is a non-destructive test where the cracks or pores, the leaks, and discontinuity can be located with the solid materials, particularly using the location and surface to detect non-magnetic materials such as aluminum, magnesium, austenitic steel weld. Locating leaks of all types. This test makes use of water washable, highly fluorescent material that is applied with a clean, dry surface of the specimen, brushed and spraying, dipping. This material is removed with the rinsing of the wiping of the clean water, soak the cloth with the sandblasting, wet dry type. Developers then applied afterwards. The black light is used to reveal the discontinuity of the welding specimen. Discontinuity of the brilliant fluorescent spots with the surface over the specimen. Alright, 9. Troubleshooting welds. Thus far, the lesson has described the process of identifying electrodes, automotive welding, type of the techniques, joint design, procedure, welding, armor, plate methods, destructive, non-destructive testing, the material provided with the basic for troubleshooting electrode with discussed in the succeeding paragraph. Each of the troubleshooting procedures discussed based on the specific malfunction directed with the result. Visual examined specimen welds for troubleshooting procedures discussed below there are based on the total 5 specimen malfunctions must likely be encountered with the maintenance unit field. Further information on the troubleshooting procedures to Technical Manual 9237. Procedure listed below are the procedure the welder would follow the troubleshooting the welder upon detecting the malfunction indicated. 1. Pore fusion. Step. The check the diameter or length of the electrode. Electrode selected should be the side of the bullet, the permanent reaching the bottom of the top to the joint of the obtain adequate penetration. Good Fusion. Step 2, check the welding current setting of the use sufficient welding current to permit adequate deposit penetration from the weld. Heavier plate would require higher current with a given electrode with a light plate. Step 3, check the welding technique. Be sure that the weave is wide enough to thoroughly melt the wide side of the walls of the joint. Step 4, check the penetration of the joint. Deposit the metal showed view of the base metal and not curl away from it, merely stick to it. Poor penetration. Step 1. Check the see if the electrode is designed for the welding position being used. The electrode should be used with the welding position for which they were designed. Be sure to allow the proper root opening at the bottom of the weld. Use the backup of the bar as possible. Chip the cutout with the backup joint. Deposit the bead of the weld metal at this point. Step 2. Check the side of the electrode being used. Do not use expected excessive penetration for the electrode. Use smaller diameter electrodes in narrowing welding groove to permit reaching for the bottom of the groove. Step 3. Check the welding current. Use sufficient welding current to obtain the proper penetration. Step 4. Check the welding speed. Do not weld rapidly to control welding speed to permit the penetration from the bottom of the joint weld. Undercut. Step 1. Check the welding cutting steady with the moderate welding current and do not try to weld to too high speed. Step 2. Check with the proper manipulation electrode. Do not use the too large of an electrode and puddle with the molten metal. Becomes too large undercut that may result excessive for the width of the width. Will cause the undercut should not be used the uniform weave. The not over 3 times the electrode diameter will be greater to prevent undercutting with the butt welds and electrode held to the nearly vertical plate, making the horizontal fill wedge undercut of the vertical plate will result. 4. Poor weld appearance. The welding technique of the proper current with the electrode manipulation technique ensure the proper welding technique with the electronic electrode using. Do not use excessive welding of the current. Use the uniform movement of the rate of the travel at the time. Check with the characteristic type of the electrode used. Electrode design with the type of the weld base metal with the position which weld may be used. Step 3. Check the welding position which the electrode is designed. Do not make the fillet weld. With a downhead flat position electrodes, you can life for the part of the position properly. Step 4, check the proper joint with the preparation. Make sure all the joints are properly prepared. Step 5, warping the thin plates. Check 1, the shrinkage of the deposit weld and metal, but select an electrode with a high welding speed, moderate penetration properties. Check the excessive locating with the local heating of the joint. Welding rapidly prevented with excessive local heating of the plates adjacent to the weld. Step 3, check the proper penetration of the welding joint, avoid the excessive root of the opening of the joint between the bars of the weld. Hammer the joint edge with the thinner of the rest of the plates before welding. Hammering and elongated edge for the welding shrinkage causes the pullback of the original shape. Step 4, check the welding procedure, either special per intermediate and alternate welding sequence pack. Step skip the welding procedure. Step 5, check the clamping of the parts properly. Clamp parts adjacent to the joint using a backup filter cool parts rapidly. 10. Conclusion. This task served to describe the theory of the principal procedure of the welding armor plate with the method destructive, non-destructive testing welds, troubleshooting the welds pertaining to electrical arc welding task complete with the test material with the lesson. Next task consists of practical exercise which are required to complete by providing the answers to the question. Alright, that completes the slideshow. From the beginning, Subcourse 08161 and 081861, Edition 8, Welding Operations 1.